Pause the video and go through the question. I guess you have gone through the question. Let's try to understand this. The first thing that we have to do is we have to assume that whatever input that the user will enter will be a 4-digit number. So that is taken care of. We can be sure that the number will always consist of 4 digits. That is taken care of. That need not be worried about any further. So let's go step by step. Let's accept user input first. So how do we accept user input? We use the input function. It's always good to prompt the user with a message. We can tell the user to enter a 4-digit number. Now on seeing this message, the user will enter a number, and we know that the input function will always accept the value as a string. So it is our job to convert it into an integer. So we'll have to typecast it to an integer and store it in a variable. Let's say that the variable that we are using is n, or it would be better if we use in, let's say IP, right? IP for input. That's a more meaningful variable name. So we have the input with us right now. Now the first thing that we have to do is point number one is we'll have to find the rightmost digit. Now remember, the input that has been entered is a number in base 10. Now whenever we are dealing with numbers in base 10, what we'll have to do is we'll have to keep in mind that the mod operation with 10. So a mod 10 operation will always give us the rightmost digit. See, we know that the mod operator is used to find the remainder. Now what happens is when you're dealing with numbers in base 10, then a mod 10 operation not only gives you a remainder, the remainder actually turns out to be the rightmost digit of the number. So how do we find the rightmost digit? To find the rightmost digit, let's call it right digit. Let's call it right digit. We can simply perform a mod 10 operation. So if we do IP mod 10, then what we get is the rightmost digit, which is also the remainder on dividing the number by 10. Now this is applicable only for numbers in base 10. So that is taken care of. Now how do we find the leftmost digit? In order to find the leftmost digit, what we have to keep in mind is it is a 4-digit number. Now, if we perform integer division of a 4-digit number with 1000, we end up getting the leftmost digit. If we perform an integer division, by integer division, what I mean is, let's say, I'll show you, I'll take an example. Let me just take an example. Let's have a 4-digit number 4567. And if I do integer division, how do you do integer division? Using the double slash. If you do an integer division with 1000, because it is a 4-digit number, what you get is the leftmost digit. What is the leftmost digit in this case? 4. So you will get 4, right? This is what happens when you do an integer division with 1000, right? Let's say instead of 4567, if it would have been, let's say, any other number. Let's just test it with another example. Let's say 8712. You get 8, which is the leftmost digit. The same thing applies for the rightmost digit. If you do 8712, if you do a mod 10, you'll see that the remainder, so the remainder on dividing 8712 by 10 happens to be 2, which is also the rightmost digit. So that's why this mod 10 operation will give us the right digit, and division by 1000 will give us the leftmost digit. So the leftmost digit can be found if we perform an integer division with 1000. I hope you remember the integer division operator is double slash, double forward slash. Instead of double forward slash, if we used a single forward slash, what we would get is the actual result, right? This is the actual result where the decimal part is taken into consideration. When we use the double forward slash, then the decimal part is ignored and we are left only with the integer part, which happens to be 8. So we are ready with the rightmost digit. We are ready with the leftmost digit. Now what we have to do is we have to raise the rightmost digit to the power of the leftmost digit. So how do we raise a number to the power? We raise a number to the power using the exponent operator, which is denoted by double star. We'll have to raise the rightmost digit to the power of the leftmost digit. So it's left to the power of right. So what we do is we do left digit, we do left digit to the power of right digit, because that is what has been asked for. Raise the rightmost digit to the power of leftmost digit. So this is my leftmost digit in left underscore digit, and to its power I will raise right underscore digit, and this will give me the result that I want. Now, after raising it, we have to print it. So what we can do is we can simply print out this expression. So if I enclose it, then the job is done. Now, if I execute this, they're asking for a 4-digit number. Let's say my 4-digit number is 4322. And if I hit enter, I find that the answer is 16, which is indeed the case. If you observe, the leftmost digit is 4, the rightmost digit is 2, and if I do 4 to the power of 2, I get 16. If you found this video helpful, do like it and subscribe to our channel. If you have any doubts, please feel free to leave them in the comment section below. I hope you found this video useful, and I'll see you in the next one. Thank you.